Today we're going to start graphing absolute value functions. Now we've already discussed the important characteristics of a parabola and how we can transform a parabola with the a value, the h value, and the k value. The same thing exists for an absolute value. An absolute value function, written in vertex form, still has an a value, an h value, and a k value. The a value is in front of the absolute value. The h value is inside of the absolute value, and because it has the minus sign, remember that means that we're looking at the opposite, and the k value is on the outside. An absolute value graph looks like the letter V. It has a pointed vertex. So it's not quite the same shape as a parabola. It's similar, but it's not the same. So let's look at these first four equations, identify how they will be different from the parent graph, and find the vertex. When we are describing the transformations of an absolute value equation, we are comparing it to y equals the absolute value of x. We've already learned that the absolute value of every number is positive. So let's look at number 1. Number 1 has an a value of positive 2, which is going to cause this graph to vertically stretch. It also has an h value, which can be found inside of the absolute value bracket. The h value is positive 3, which is going to cause the graph to move to the right 3. And it has a k value of positive 2. And because k is positive 2, it is going to move the graph up 2. The vertex still located at h and k, and in this example, the vertex is at positive 3, positive 2. Let's look at number 2. Number 2 has an a value of 1. Well, that is the exact same a value that can be found in the parent. So this graph is not going to vertically stretch or compress. The h value can be found on the inside, and it's the opposite, negative 4. That's going to cause this graph to move left 4. The k value is negative 7. So that's going to cause the graph to move down 7. And the vertex is located at negative 4, positive 7. Pause the video, copy down equations 3 and 4, and see if you can identify the transformations and where the vertex of each graph will be located. Okay, so let's take a second and look at numbers 3 and 4, and let's see how you did. So in question 3, a is 3. And remember, whenever the absolute value of a is greater than 1, it causes the graph to vertically stretch, which means it's going to appear narrower. H can be found inside of the absolute value, and H is positive 5. So it's going to shift to the right 5. K is 0, so this graph will not move up or down. When we look at number 4, A is actually negative 2/5. So that's going to cause two transformations when we compare it to the parent. The first is that because the absolute value of A is between 0 and 1, or the absolute value of A is less than 1, it is going to reflect across the x-axis, and it's going to vertically compress. So because the absolute value is less than 1, that's going to make it vertically compressed. And because it's negative, it's going to reflect across the x-axis. H is 0, so it will not move left or right, but because k is 9, it will move up 9. Okay, so now we're ready to graph. Let's look at example 5. And the first thing we're going to do is describe the transformations when we compare it to the parent. So the A value is 2, and that's going to make this graph vertically stretch. The H value can be found inside of the absolute value, and it's the opposite. So H is -4, and that's going to move the graph to the left 4 units. Lastly is K, which is +3. Oops, sorry, -3, and that's going to move it down 3. Now, the domain of the absolute value is also all real numbers, just like the parabola. And we'll look at the graph to see if we can figure out what the range will be. So, question B is referring to the parent, which is y equals the absolute value of x. So let's go ahead and graph that function now. So let's choose our x values. So I'm going to use -2 to +2. Remember, when we take the absolute value, we're looking at the distance from 0. And because it is the distance, it will always be positive. So the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So let's go ahead and graph this. Now, notice that when we graph it, it's a straight line, and the vertex is pointed. It's a V. Trying to make this perfectly straight would be so much easier if I had a ruler. Okay, so that's what our parent looks like. So as we look at it, we can see that the y values are only above 0. We do have a y value of 0, but everything else is greater than 0. So that means that the range of the parent is from 0 to infinity. And we can verify the domain because we have negative x values and we have positive x values. And these numbers extend from negative infinity going towards positive infinity. So let's apply our transformations. If you recall how we did transformations when we were looking at parabolas, we're going to do the exact same method here. I'm going to add all of my h values. I'm going to add h to x. So h is -4. So we're going to go ahead and add -4 all the way down. And then we're going to take our y values and multiply them by +2, and then add a -3. I was going to say subtract 3, but adding a negative is the same as subtracting. So go ahead and pause the video to find what our new values will be for our transformed function. Okay, so let's look at our transform x and y values for g of x. After I added -4 to all of my x values, these are my new x values for g of x. And then I took all of my y values and I multiplied them by a, which is 2, and then I added -3. And these were my 5 new y values for g of x. So now, when you plot these 5 ordered pairs on your coordinate plane, this is what our graph looks like. And as we can see, all of the transformations we predicted are true. The red graph is vertically stretched or narrower. It did move left 4, and it also moved down 3. So what is the domain and range of our red graph? Well, when looking at our domain, notice that we have negative numbers, but the graph eventually will go to the positive side of x. So your domain is actually negative infinity to positive infinity. And in actuality, that will always be your domain for every absolute value function. But let's look at our range. For our range, we definitely have a lowest y value. The lowest y value is -3. So this graph will never go below -3. So our range is y is greater than or equal to -3 or -3 to infinity. Let's graph one more example. Feel free to copy down g of x and do as many of the questions or parts of example 6 as you can. And then after you try to do it on your own, hit play to finish the video. Okay, so let's compare what we have so far. So our three transformations of g of x from f of x is that because a is negative, it is going to reflect across the x-axis. H is -2, which means it's going to move to the left 2. And k is -3, which is going to shift it down 3. As you can see, I started with our parent, and these are my 5 x values for the parent, and I took the absolute value of those 5 numbers. And when I plotted that, this is what my parent graph looked like. In order to apply the transformations, I added h to all of my x values. And h is -2, so these were my new 5 x values. But then I took my y values, I multiplied them all by -1, and then I added -3. And these are the values that I received. So after I graphed it, this is my parent, which is f of x. This is my transformation, g of x. So let's talk about the domain and range. Starting with the parent, when we look at the parent, we notice that our x values are both negative and positive. It's going to continue to the left, from the left, going towards the right forever. So our domain is negative infinity to infinity. However, our range will not go below 0. So our range is from 0 to infinity. Let's look at our transform function. Again, our x values are both positive and negative. So the domain of g of x is negative infinity to infinity. Now this graph is facing downward. So the lowest is actually negative infinity because it's going to keep going down forever. So my lowest is negative infinity. The highest y value right here is -3. And again, that would get a bracket.